And we're going to welcome on stage a woman from King. So let's give it up for Anastasia Kuznetsova. Did I pronounce that right?
No.
No, okay. Sorry. Okay, tell me.
It's Anastasia. Yeah, but the surname was good.
Okay, that was what I was worried about. But okay, very good. So you're a data scientist at King, and you're using analytics and data science to bring actionable insights to the game development teams building the Candy Crush Saga. So
yeah, absolutely true.
Yes. So today you're going to tell us a little bit about what you're doing, experimenting. You have a lot of experimentation going on. So this is what your presentation is about. So here's the clicker, and you have your presentation set up for you.
Great. Cool. Thank you very much. I guess the clicker is not set up right now at the moment, so we're downloading some software because I was not ready with the right phones I didn't send my phones, so we couldn't run it on the other laptop. But just a brief intro to what I'm going to be talking about today. I'm going to talk about how we are working on improving user experience, running experiments in our games, pretty much doing A/B testing in our games. The keyboard cannot be identified. Oh. Japanese? Okay. Oh, yes. Woohoo. So that works. Yeah, so I understand I'm standing right now between you and your afternoon fika, so I'll try to be short and snappy. And just to encourage temptation in you, I'm going to talk about candies, because I work for Candy Crush. So a little bit about myself. I've been a data scientist at King for over 2 years, and I've been working mostly with Candy Crush and a lot with game development teams, where I've been encouraging and helping them out in planning, designing, and running experiments in our games. If you've only heard about King because of Candy Crush, I have some news for you. The company's been alive since long back from 2003 and goes way beyond Candy Crush. So actually in 2003, the company started off as a website where you could play Flash games called Royal Games. In 2011, it launched its first game on Facebook, which was Bubble Witch. And at around the same time, they started running the first experiments and the first A/B tests. Of course, it was not as advanced as it is now, but they had to start from somewhere. And in 2012, as everyone probably heard, we launched Candy Crush on mobile, and half of the world was playing it pretty much, of the people who had the mobile phones back then. A little bit more about different games we have. It's not only the Candy Crush and Candy Crush franchise. We have 4 other different franchises, but Candy Crush franchise is one of the biggest ones. And for the past 5 years, we've been in the top grossing apps for both Apple Store and Google Play for 2 of our games, which is Candy Crush Saga and Candy Crush Soda Saga. I'm working for the original one, so I'm going to talk about it today. So a little bit more on the data side, since we have a data conference. As of Q3 this year, we have over 260 million monthly players. Recently, we registered the day with the record number of events. So it was around 60 billion events that we received in our database. And it's everything that our players do in our games that we track and can store, and then use to analyze the experiments. And every year in Candy alone, we do over 100 different features or improvements in our games. So today, I think I checked in the morning in our internal tool, and these 200 experiments actually translate to around 800 different A/B tests of the actual A/B tests that we assign to our users. So that's to say that we experiment, and we do experiment a lot. And that's the background that I come to you today, and the place that I'm going to be talking to you from. And I will try to answer 3 questions today about experimentation. So first of all, of course, I want to try to explain or mention a little bit what is experimentation, just to give a good background. Then I'm going to focus on how we're working on embedding the experimentation process in our product development flow. So how do we work with the game development teams, making sure that we're doing experimentation the right way. And the third question will be more on how we use tech and tools to support the experimentation process. So how can we automate and streamline as much as possible the experimentation process. So let's start with what is experimentation. When you try to search in Google what is A/B testing or experimentation, the first example that comes up the most of the times is the one from the Obama campaign in 2008. So that was the start of A/B testing on the web. And imagine, as the campaign manager for Obama, you had to decide how are you going to design your landing page so that you have the most sign-ups and the most donations from the people that get to this page. And imagine you have to choose between two variations, so either number 1 or number 2. You can do it in many different ways. You can use your gut feel, you can do demographic research, you can ask some experts. But what they did and what they became famous for is they ran actually A/B tests on their web page. So they ran more A/B tests than these two, but one of those pictures or one of those versions is a winning one. The one that earns 40% more signups and around $60 million in donations. So I'll try to be a bit interactive here and ask you, by the show of hands, how many of you think that version number 1 was the winning one? OK. I don't know if the others have seen this case before or not, but actually they were correct. So the version number 2 was the winning one that earned 40% more in signups and $60 million. So this is A/B testing in a nutshell. You have to define what you want to test, what you will test. You will have normally a version that you define as a control or the baseline against which you will measure the change. And you will have the version, the new or test experience that it will show to your users. And of course, very part of it is defining how are you going to measure that you succeeded with the test. So in the case of the Obama campaign, they started off with defining that they want to earn more money and they want to get more donations. So they decided that they want to increase the rate of the donations. But they could look at something else. They could look at the sign-up rates. And if you work in any other different company, you can look at many various metrics and KPIs depending what your business goal is. So for example, if you work in Uber, you might want to increase the number of rides that are completed on your app. If you work in Airbnb, you're optimizing your booking flow. You want to increase the number of locations booked. If you work in Amazon and you're optimizing the purchase flow, you want to look at the purchase volume. And all of us know that Facebook was experimenting a lot on their newsfeed. And maybe if you're pre-2016 Facebook, you would try to increase the amount of time people spend on the newsfeed. But after all the movements about the meaningful time spent in the applications and reducing the pointless time spent in different applications, maybe you would want actually to look at something else, like quality of the time spent in the newsfeed. And at King, depending on what game we're working on, depending on our goal for the experiment, we also look at various KPIs or various metrics from game rounds played to spend to number of players, retention of players, and many more. So in a nutshell, experimentation is something that improves your user experience, but not only improves it, but also gives you a real business impact based on which you can measure this improvement. So now I'm going to talk a bit on a topic that I'm more passionate about. And actually, this is collaborating with different other functions and working cross-team to embed experimentation in the development flow. So some of you may come from agile environments, some of you may not, but I think everyone would be familiar with the process of the product development or problem-solving process, where you start with defining what's your problem and what's your hypothesis on how to approach solving this problem. Then you define how you design a solution around it. Then hopefully you implement it or develop a new solution. Then you go on and doing some A/B testing also hopefully. And then you optimize maybe your solution based on the A/B test. And at the end, you come up to the decision-making part. This process can go in the loop as well. So you may start, after you make a decision on one of the solutions, you may get the information that will drive another problem and another hypothesis. So where does the experimentation fit in this flow? An obvious answer would be where it says A/B testing. And that's the answer that a lot of companies start from working with. But if you're a data scientist, you know how you analyze the A/B test results, you know the limitations. Maybe you want to also empower the decision makers of your product to make better decisions based on the insight that you got from the experiment. And maybe to make the analysis, actually, you have to know how the hypothesis was defined. And maybe knowing how the hypothesis was defined and having a lot of inside information about other experiments, you can inform the team that's building your product on how to better define the problem. And I guess you're kind of getting where I'm going with it. So in general, our idea at King, when we work close to the game development, is that we're trying as data scientists to be the most embedded in the product development cycle we can. And we're trying to inform or help to encourage data-driven decision-making, data-driven experiment design for all the different functions that work on building our games. So there are different types of collaboration that come in different parts of this process. And I will talk about several of them. So in the design part, it's more about how you're collaborating and defining the problem and making sure that everyone is on board with how you define a hypothesis and what you're going to measure the success on. And the technology part, it's coming across different experiments. So it's not per experiment that you're building infrastructure and technology and maybe streaming tools that allow you to analyze the performance of the experiment, but you do it kind of preemptively. And the analytics part is very important to also support your fellow data scientists on building common tools that you can use for automated experiment analysis. So I'm going to talk about 3 of those areas in a bit more detail. So let's start with the design. This is the part that encourages the most communication that's been mentioned on this stage several times already. There are different frameworks on how you can define how you want to communicate with artists, developers, user experience researchers, and designers in your teams to make sure they understand what's experiment and how they can benefit from using experimentation. But I like to start with the why. So maybe some of you will be familiar with Golden Circle or the rule of starting with the why, which is promoted by leadership coach Simon Sinek. But pretty much the framework is just 3 simple questions that go in the order of importance, where first you define why you want to achieve something. Why do you have this problem? Or what is the problem that you're trying to solve in your product? Second question would be how you want to change it. So how you want to address this problem and the changes that will happen in the user behavior, the changes that you want to encourage in the user behavior. And the last question will be what will be the actual impact on the game, so how those changes translate to the business impact. And this is very simple questions, but it's actually super useful because of this simplicity when you're working with different other functions that are not probably data science informed as much as you. To ensure that everyone understands why are you doing this, how are you doing it, and what is going to be the business impact. The next important part is, as I mentioned already in the beginning, is that the change should be measurable. So this is the case from, which I also like very much, from Google. I think in 2008, they ran an A/B test where they tested 41 different shades of blue for the links to advertiser channels that they had in Gmail. And this was, there are very polarized opinions about whether you should or should not do those kind of A/B tests where you test the minuscule changes in your product. One part of the opinion is coming from the designers, and one of the top designers at Google claimed that he actually quit because of this test, because he felt that his expertise is not relevant or important enough if they're trying to test those small changes and can't trust him in choosing whether this shade of blue is better than the other shade of blue for the link. However, the other part of the opinion around whether you should do those kind of A/B tests is supported by data. So when they actually did this test, they found out that a little bit more purplish shade of blue over the course of the year earned them $200 million coming from their advertisers. So this was definitely a huge success, but it cannot be one fit for all as well. Because it was Google and because it was Gmail, a product that's used by billions of people probably, they actually had the capability to measure those differences. But if you work on something that's smaller and you can't measure the difference between one shade and the other shade of the color for your button, maybe you have to balance out those two areas between the design and the experimentation. So when you choose what you want to measure, try to look for something that's actually reflected in your data and something that you can see, if not with your naked eye, but maybe with the use of the tools and statistics. So when you already define the design part as a hypothesis-driven and measurable change that impacts your product, it's time to move on to the tech part. And this one is probably the most kept in obvious part of my presentation, because I would want to say something like, if you don't have the data, you can't have the learnings. And that's something very obvious. Like if you don't have a data warehouse and infrastructure, then you can't know what was the impact. But I encourage you to go a little bit beyond of this thinking. So it's not only at the end of the experiment that you need the data to analyze how the experiment performed. It's also very useful to look in real time. And it's something that we really benefit from because of our user base. We have several real-time monitoring tools that allow us to see if something goes wrong with the experiment that we're running at this time. So this one is a screenshot from one of our internal tools, which is a simple aggregate of our core KPIs. So like there are game starts, game ends, number of errors that there are in applications, and we see them compared to a day ago and 7 days ago. So this is a very, very, very simple tool that allows us to see if there are any changes in the trends of how our players use our applications, or if there are any errors when we're starting off new experiments for them. So here we see that everything is going OK, so that's great. But if something is actually going wrong, we also can use something more sophisticated. So we have several tools that detect anomalies in the time series. Some of them are heuristic-based, some of them are machine learning based, but pretty much they are used for alarming us in cases there is something going wrong with the metrics that we're targeting. So for the technology part, I just want to mention that having something flexible and tailorable is super important for your experimentation, because it can allow you to catch any errors or any problems in real time before you actually finish the experiment and decide that today I'm going to analyze the data. So yeah, when you have the infrastructure and the design, it's time to move on to the analytics part. And this one is most probably relatable to the data scientists here, the part where you get the data, crunch the numbers, make the graphs, and try to make sense of all the performance that you see. And here I'd try to take a step back and actually remember that I work in a gaming company. So there will be some screenshots of Candy Crush. So yeah, imagine that you play Candy Crush. I hope that you all do, of course. But let's say if you didn't, this is something that we usually run in our games. So we have like short time limited events where we say to our users or our players, hey, like we have this cool thing. If you're going to play levels in Candy Crush and earn a certain number of stars on the levels for winning them with the highest score, then you're going to get some rewards after the timer expires. So usually those kind of experiments or those kind of events drive player engagement, meaning that they just generally tend to play more. And when we analyze the performance of those kind of events, we may see something like this. So this is the relative difference between the group that sees the event and the other group that doesn't in terms of the number of games played. So the group that sees the event has around 3.5% increase in the number of games played over time. So that looks great. But something that's important to be mindful of in this case is, where does this change come from? If I take the example of the games played KPI, I can break it down for other KPIs. So in this case, the number of games played may be influenced by the fact that we have more players, but they play less games per player. Or the other way around, we may have less players, but they play much more in our game, and that can be even more concerning for us. And maybe the decision that we make based on this breakdown will be very different. So the underlying metrics, when you're looking at your global KPI that you define it as a target metric for this experiment, are also very important to look at. Now let's go back to the example, and let's say that the underlying metrics look fine. Both we have more players and they play more, so that looks great, and we want to continue looking at the performance of this test. Do you think, can we make a decision based on only this sort of output, so only this graph? I will answer to you that no. It's important to maybe look in the past and make sure that we are very well informed on something that happened before the test. So in this case, let's say that was actually the third time we ran this event. So this was event number 3 that we looked at. But we also did run this event for the same players twice before, and the performance was actually better. So the uplift between the test and control group was higher. And knowing this information allows us to make a more informed decision based on the previous performance of the groups. And that doesn't only come from the cases where you already use the same population for the test, but also it can be simple pretest bias where your assignment didn't work in the right way, and maybe you have more spenders in one group and more new users in the other group, and then you have some sort of data that you can't reliably make any decisions on. So looking at the pretest imbalance is also very important when you're analyzing experiments. The third example I have is actually converse to the second one. So looking in the past is important, but looking in the future is also very important. And in this case, let's say we don't know anything about the future. We only looked at the first event that we ran. There is no pretest imbalance before the start of the event, and we see that the number of game rounds increases continuously, and we're very happy about it. And it's very tempting, both for data scientists, but even more for business-related people, or product-related people, to make a decision in this case that, yes, we like it, we run it for long enough, we want to have immediate business impact, and we want to release this event for everyone. However, it's important to wait until the stationarity, until the time series of your metrics stabilizes over time, because if we would only look at the first event, we would miss out the whole range of the performance that happened in the future. So making sure that you have long-term groups, holdout groups that don't see the experience and based on which you can measure the long-term performance is also very important. So this part is more about stationarity. And why I mentioned all of those areas is because tools that you build in-house for analyzing your experiments actually help you out in making informed decisions and help you out not to forget about all of those small areas that you have to look at to make sure that your data is reliable. So this is a screenshot of our internal tool that we use for automatic analysis of the A/B testing. And here you can see that we have different validations for the test. So we know that the crashes are not increasing, or we know that there is no skew between the sizes of the groups that we run the test for. And as well as addressing the first point of the underlying metrics, we not only look at the KPI or the metric that we defined as a target one, but we also look at the breakdown on different other metrics and KPIs that we use at King to analyze the performance of our games, to see that there is no negative trends that we would like to address before making the decision. So the statistics and tools married together are a great support for data scientists to help them out to make more informed decisions, and actually to free up their time to work more on machine learning or modeling, or working closer with the teams and making sure that everyone understands the data-driven experimentation. So as a take-home message today, I'd like to encourage you to think about communication while you're doing the experiments where you're building and planning experiments. And as I mentioned, there are different types of communications throughout the process of the product design, where in the design part you have to make sure that everyone's on board on understanding how you build the hypothesis and how you're going to measure the change, making sure that you have sufficient infrastructure and tech to support your decision making, and making sure that your analytics part is unified and streamlined, that your data scientists have more time and more hands to do more advanced analytics, and at the end make sure that you build more exciting things in your products. Thank you so much for your time. Have a nice rest of the day, and I'll be also happy to answer your questions either now or after at the fika.
So do we have any questions before Fika? Yes.
Thank you. So my question is, do you have any ethical aspects on your work as a data scientist?
Yes. Yes. Well, there are various ones. If you work on monetization or spend, there is like price discrimination that you wouldn't want to do in your product. For example, there is also a part where you have to ensure that everyone has the same sort of experience in a way that everyone has access to the same experience and that you're not differentiating people based on some particular metrics. So yes, that's pretty much the answer. It really depends on the product and it really depends on the feature that you're working on if you want to make one decision or another. Like you can't only base it on data, you have to also take user experience into account.
Yes, more questions.
Thank you. Hi. First, I want to start with a big congratulations. 6 years. Wow, I didn't really understand that Candy Crush has been along for so many years.
Thank you.
I think I downloaded it like for the 5th time now, so I can't get rid of you.
Yes.
My question is, since you are so successful, do you think it is like the data analytics and the A/B experiments you're doing, do you think that is a big part of your success? Or are there more reasons?
Of course, as a data scientist, of course, I'm very tempted to say that, yes, that's why we're very successful. But I think, well, there are different recipes to success. And the fact that King has been very data-driven from the very beginning, so all the games were built with keeping in mind that we need a good ETL, good data warehouse, that we need a flexible structure or infrastructure to have ability to run experiments, to do A/B testing, to do analytics on our games. Definitely it influenced the fact that we're still going strong. But of course, like we have nice art and nice characters and interesting like background and envelope of how our players can interact with the game. And there is no way that I at least can define what is the ratio between analytics and the core game in terms of success of Candy Crush. Yes.
So, and you also have a psychological theory behind the game, sort of. I'm thinking about reward, a psychological mechanism that is kind of, I think, for you, especially for Candy Crush, well-defined, because you tend to continue to play it because you get these rewards. So I'm just saying, in your hypothesis, you have a theory that you can actually use from the beginning.
Yes.
Not every company would have that.
Yes, and
Right.
there are different drivers. So there are several drivers for the engagement of the players for different games. And for casual games, it might be rewards or continuity or something else, or having an ability to zoom out and just play something nice while you're on a commute. So yes, there are different drivers that we try to address when we're building different features, and we try to be in a good range based on all the drivers.
Anything else? So we're 1 minute past 3, which is Fika time. So no more questions. So thank you so much for sharing your story.
So much.